Hello, Mr. Brian. In this video, I'll be presenting my AI final project, which is an AI fitness and posture coach. So I use teachable machines to create two different AI movement recognition systems using machine learning and computer vision technology. I made two different AI coaches. The first AI recognizes 5 different yoga and fitness poses. You have the tree pose, the plank, squat, T-pose, and the warrior pose. My second AI focuses on posture and ergonomics. It recognizes two different sitting postures. A healthy sitting posture, which is normal, and then one where you're slouching, which is a bad sitting posture. And the goal of this project was to design, train, and test working AI models that accurately detect body positions and movements in real time through my webcam. This technology can really be used in so many real-world situations like fitness coaching, sports training, posture correction, injury prevention, physical therapy, or rehabilitation programs. So having this AI with you all the time, imagine in the future, you're just sitting down in the chair, you really want to fix your posture, but you keep forgetting and like you feel it's more comfortable, but then you have the AI always watching you. It's like, yo, you need to fix your posture. Lower your back. And then boom, you just do it. You know what I mean? You always have this AI with you, and in the future this can be insane. So for this project, I had to analyze body movement. So I had to study human movement and body mechanics. My role was to train this AI system to recognize and classify movement patterns using skeletal tracking. So I researched each of the poses I chose. I made sure I was doing them correctly. I tested them out. I tried making the teachable machine reach 100% on each one so that people really know if they're doing it correct or not, and it does not just mess up. So anyways, let's move on to research and planning. Before I had to create these models, I researched proper exercise form and posture positions to make sure the poses were clear and consistent. I also explored teachable machines pose project interface to understand how pose estimation and skeletal mapping actually work, because it is very important to know how it works before you even start. Unlike normal image recognition, which we did last time, the pose project focuses on tracking body key points instead of just analyzing the pixels. This allows the AI to understand body angles, limb positions, and movement patterns way better. And I actually kind of did suggest this project in the last video I made. I said like it would be cool that we did poses because there were some letters I couldn't actually do movement for. So it's kind of cool seeing how we progressed into this teachable machines website thing. One important concept I had to use in this project is called pose estimation. It is a subset of AI and computer vision that detects human figures and tracks important body key points like my shoulders, elbows, wrists, hips, knees, and ankles. So when I was recording myself, I could see these blue dots everywhere, and they were tracking the key points I was talking about. So the AI analyzes these points to understand how the body is positioned. This process is also called skeletal mapping. It connects the body key points together to create a virtual like stick figure looking thing with the blue lines. And then the AI studies the angles, relationships between different body parts to create these movement and poses accurately. There's also something we learned about this year called supervised learning, which this project uses. It is basically when the AI learns from labeled examples. So obviously I have examples like the tree pose, which has its own class, and the squat has its own class, and then the good pose for healthy sitting has its own class. Everything has its own class. And the model learned patterns from these labeled classes and later used classification to predict movements from my live webcam input, which I'm going to show you in a bit. Another key thing we learned this year was dataset and data collection, which also these AIs use. So I had to train them by creating datasets for every movement class. A dataset is just a collection of like examples that I can use to teach the AI. So as the rubric says, I need over 150 photos to reach the full mark in that category. So obviously 150 different frames from my webcam. I uploaded them, and I made sure my full body was visible. I made sure that the lighting was good enough, the background was good enough, and the camera angle was staying consistent. Even though for the plank I had to lower it a bit so you can obviously see me on the ground because I had to show my full body. Anyways, I also slightly changed my distance and body positioning so the model could learn movement variations instead of just memorizing like an exact position, like, oh yeah, standing still here and he was standing still before, so that's that. It has to actually understand instead of just organizing. And I had to organize, label everything into the dataset correctly by separating every pose in its own class, and this improved the model's like ability to classify movements accurately. When I was training the model, after like collecting all the data, I had to train it, and during training I had to analyze the skeletal coordinates and search for movement patterns in the dataset. I monitored how the skeletal lines were aligning with my body to make sure the tracking was actually accurate. Instead of just always testing it, I would test it myself by actually checking up on it. And I adjusted the training settings and retrained the model multiple times to improve the performance and reduce the mistakes. When the AI was confused on like certain poses when I was trying them, I had to add additional data, and I had to focus on the limb angles and the model, the stuff that models struggle with. Anyways, I know it's getting a bit long, so I'm just gonna quickly move on to the other key things we learned this semester that really apply into this project. We have classification, which is the process where the AI is actually predicting which pose or posture is being performed. So the class with the highest confidence becomes the AI's actual prediction. Anyways, overfitting, it is a challenge in machine learning. So overfitting happens when the AI memorizes the training environment way too specifically, or it struggles to work in different situations. Like the model only recognizes movement in my room under one lighting, but when I go somewhere else, it's not like recognizing it the same way. And to reduce overfitting, I had to collect a lot of data, trading data. I had to change my positioning slightly every time, and I use multiple movement variations. This helped the AI generalize movement patterns more effectively. See, in this video, I'm only gonna put, I think, one live example of me doing it in this room. But while I was actually working on it, I obviously moved to another room, different lighting. I actually tested it out to its best capabilities. And trust me, it's very stable, which you're gonna see in a bit. Anyways, now I'm going to demonstrate my first AI model, which recognizes yoga and fitness poses. So I'm gonna set my camera up, I'll be back, and then I'll voice over it. So let's do that. So I'm going to start off with the T-pose, which was detected instantly. It was amazing. Then here we have the squat, which was also perfectly detected with no issues. Here I had to lower my camera a bit so I can fully perform the plank on camera. As you can see, fully detected, very easy for the AI. Here we have the warrior pose. As I perform each movement, the AI is going to use pose estimation and skeleton mapping to analyze my body position in real time. And lastly, we have the tree pose, which is very well known in yoga. See, imagine in the future when you're at the gym trying to lift weights for the first time and you're lifting it wrong, and then the AI is like telling you, no, this is how you actually do them properly. Like, that would just be insane. No more need for fitness coaches, no more need to actually going online and researching them. You have an AI correcting you all the time. Now I'm going to demonstrate my simple second model. I wanted to make two models because I feel like the first one was very good. You know, it does everything the rubric wants. But this second one was kind of that little thing that I want for me, since I struggle with it a lot. My posture is always really, really bad. I always slouch or like lean to the left or something like that. So the purpose of this AI is to demonstrate how it could be used to monitor posture and improve body positioning. So here I'm testing it out. This is the good pose. As you can see, it's good. And then as I kind of slouch down, it marks it as a bad pose. So yeah, and I kind of like how it transitions, like the percentage from good to bad. It's like you know how good and how bad you're doing it. You get what I'm saying? So over here, when I move to the side, you can obviously see that is a very bad pose. And now this good pose, and then bad pose. So yeah, it works very well. So bad pose, good pose. And I just keep doing this just to mess around with the AI. And then over here, I'm leaning to the left and it still shows that it's a bad pose as well. So that's how powerful this AI is. You may not be noticing these changes in your backs when you're sitting improperly, but after a few years and constantly doing it, it's going to be really bad. See, I have uncles with many back problems because of this. They don't sit right. They work in an office. They're always sitting all day. And it's really, really, really painful. Like, it's horrible. So I try to avoid this, which is why I actually made this AI in the first place. Anyways, moving on to my reflection, because this is very long. I'm sorry, sir. One challenge for me was the lighting, because the poor lighting is a real challenge, because it could not correctly detect my limbs, which I needed it to happen. And my room lighting is not that good. I'm using what I'm working with. I cannot go into a professional studio with perfect lighting. And another challenge was the camera angle. See, I had to have it the perfect height. Sometimes I had to change the height a little bit because I cannot perform the plank with the same angle as me performing a T pose. It's literally very, very hard. Or else I'm gonna have to be very zoomed out. Quality will be very bad. So yeah. And if I continue this project in the future, I would definitely train the model using different people, increase the data set, add more movement classes, and improve performance in different environments. And possibly in the future, you could start seeing mobile apps like smart coaches that are AI. By creating two separate AI systems, I demonstrate how AI can be applied to fitness, posture correction, sports training, healthy technology. And this project has helped me understand data sets, machine learning, supervised learning, classification, overfitting, computer vision, real world AI applications, which we've covered all year. But this AI really helped me actually apply it and use it. So it showed me a lot about how AI can analyze human movement and provide actual useful feedback that could improve health, performance, and fitness. Thank you so much for watching my presentation, sir. I'm gonna miss having your classes. And yeah, bye.